I've been looking for a low-cost, simple way to do reflow boards occasionally. Not a production environment, but just every once in a while do some surface mount boards. And I've looked at various projects that included controllers and toaster ovens and so forth. And they seemed pretty expensive and complicated and worked well for some, but not for everyone. Particularly dependent on placing a thermocouple at the right place so that the controller would do its job correctly. Then I found that a large number of people prefer hot plates or even electric skillets to do this, finding that the result is more consistent and that there is more even heating and fewer hot spots, fewer scorched boards and parts. So I decided to try a version of that, starting with this device, which is the $10 Walmart hot plate. And I should say at the outset that all of this is going to apply to people essentially in the U.S. who have access to Walmart and Home Depot and Ace Hardware and are on 120 mains like the U.S. has. So this is the hot plate. It's very simple, just has a temperature knob and that's it. So let me show you. Here we go. What I found was, at first I decided to build a controller for it, thinking that I would have to do some fancy footwork to get it to do what it's supposed to do and not overshoot, which is the big risk, of course. But the more I tuned the controller, the more it came down to just being a simple two-stage heating process where you turn the hot plate on at full power for a period and then turn it off for another period and then turn it back on again for a period, and then after that the reflow takes place and there's no overshooting and everything works fine. And there's no need, by the way, to monitor anything. You don't need a thermocouple. You don't need a controller. You just need a stopwatch. Now, the way this works is, from Home Depot, a $5 circular saw blade. I just picked the cheapest one I could find. And this is a steel blade, of course. And you'll notice that it's resting on 3 screws. These are the modification that I made to the hot plate. You take the bottom cover off with this single nut here and washer, and then that just lifts away from the temperature knob. And then you'll see where the 3 existing screws are. These are longer versions of that screw, and I got those at Ace Hardware. And I'll put in the description exactly what all of this stuff is. So basically, that's the idea. You take a board and put it on there, everything starting out at room temperature, and then you follow the timing. And this would be, of course, for leaded solder, 6337 leaded solder paste. And it's essentially on for 102 seconds, off for 150 seconds, on for 46 seconds, and then shortly after that ends, the reflow begins. It may begin a little early, but mainly it's after that last turnoff. And then another 100 seconds can pass after that last turn off, during which the temperature will continue to increase. And you can, if you don't want to wait around for that and subject the board to more heating, you can simply, with oven mitts of course, or hot pads, just lift the saw blade carefully and put it aside on some surface that's heat tolerant and let it cool off more rapidly than it would sitting on the hot plate. Because the heating elements, change state fairly slowly. But you can wait for the full 100 seconds after that last power cycle, and it still will be fine. Now, placement of the board is not particularly critical, and I was very surprised to find that even if you place it over the center hole, that reflow will still take place, although somewhat more slowly. So, if you can avoid the center hole, if it's a small board, then do that, but otherwise, just wherever you want. And you might even, if depending on the how tricky and critical this is, if you can gently, you'd need something, not your finger of course, but something else to just gently move it around every 20 or 30 seconds so that the board kind of shares the wealth on that center hole, and it would probably all end up reflowing about the same time. Now, as far as controlling the power is concerned, you can use the temperature knob. You'll hear it click. It's on. It's either fully on or fully off. There's no gradual heat in here. So, or you can leave it on max and just plug it in and unplug it at the right times. That's really just as easy. Two things that can affect whether this is going to work the same way it worked for me, and that is if your room temperature is different from mine, you'll get more heat, and if your mains voltage varies a lot, that can affect it. But generally this is pretty forgiving. And of course, if I would encourage you to try an old board and just put some blobs of solder paste on it. You don't need parts. You just want to know when the solder paste melts. And just get an old board and do that, and then try this. If it seems to be heating up too fast, you can cut back on either one or both of the power periods. And if it's too slow, then you can increase them. So, it's just a question of trial and error. But I've done a lot of trial and error with this, and the numbers I came up with work pretty well. The cost of this, the hot plate is $10 roughly at Walmart. The saw blade is $5 at Home Depot, and the screws at Ace Hardware were a couple bucks. So you're looking at a total cost of this less than $20. I made the controller, and since I've done that work, I included it in the GitHub repo, which has information on this method. If you want to build the controller, you're welcome to, but all it does is just more precisely go through the same sequence that I do manually now. So there's really, you don't need a controller, and you certainly don't need a thermocouple. But it's there in the repo if you want to make one. Well, at this point, I'm going to show you a video I did of this board reflowing, and you'll notice when we look at that this little resistor over here, and I had it placed, I'm going to say something like that. This resistor over here reflowed before the end of the soak period. In addition, this resistor flipped over on its back. And this is the fault of the crappy solder paste I'm using, which is long expired, and of course I don't have any kind of a stencil to apply the paste, so I just put it on here with a toothpick, and there's way too much. So as the flux tries to evaporate away, it can push the part off, and that's what happened to this one. But these worked all right, and this one worked all right. Now they're bridges, of course, because there's way too much solder paste, but you'll see this reflows pretty well. Have in mind before you start where you're going to put the saw blade when you remove it, because it's going to be hot, and you want a surface that will not be harmed by it. Oh, one thing I wanted to mention. Of course, the controller would eliminate the need to watch the stopwatch, because it would just do everything automatically. But a better, simpler solution to that might be for you to just make a voice recording of one session with, kind of 5-second countdowns to each change in the power level. And then for all future sessions, you could just play that back on your phone and listen to it, and you don't have to watch the watch anymore. So I think this could be pretty convenient for a lot of people. So let's go look at that reflow video. So I have the hot plates set up here with a board it's a Banggood practice surface mount soldering kit, and it's not a circuit really, it's just a bunch of part layouts, and they give you some random parts along with it. So I'm going to use the controller that I designed to duplicate the manual procedure, but it'll be exactly the same timing as anyone else would use manually. And so I'm going to start it right now. So now it's at full power, and there's not going to be much to watch on here, so I'm probably going to speed this up and get to the final reflow stage as soon as possible. It appears the resistor over on the left has already reflowed, and that actually is a little bit fast, but I don't think it's going to hurt anything. Now the power is just turned on again, so we'll go about whatever it is, 44 seconds, and then shut off again. Okay, the power is now shut off, and we'll see when it reflows. And we're 20 seconds after the shut off, and it looks like it's pretty much done. Now normally I would remove the saw blade from the hot plate and put it somewhere else to cool off, but I'm going to let it go till the end, till it reaches what I think is approximately maximum temperature, so we can see what happens to the board if it's left on really too long. But remember, the power has been off now for almost a minute, so the gradual temperature increase will not lead to any major overshoots. In fact, my guess is that this tops out just above 200 degrees centigrade Celsius, and that's not going to hurt anything. Okay, we're now done. Now I'm going to take this off of the saw blade and show you the bottom of the board. And as you can see, I hope, it's not scorched or burned in any way. So that's pretty much the way it goes. So it's important to follow the timing. You know, if you want to, you can build a controller, but all it does is just duplicate that period of 2 power cycles, and you don't really need a controller for that. So anyway, I think this will be a really inexpensive, you know, under 20 bucks altogether, really inexpensive, simple and safe and easy, gentle reflow process that pretty much anybody can do.